Hello, my name is Brandon Essebag, and I am demonstrating the multi-control counter CircuitVerse circuit for my digital logic design class at Cal Poly Pomona for the spring of 2023. Welcome on, Professor, and if you are not my professor and you have just stumbled upon this video, absolutely welcome. I hope you learned something along the way. So, this assignment was to create a circuit that can count up or down either even or odd numbers between 0 and 15, and could also have an alert override that toggles the output between 0 and 8 every clock cycle. And the design constraints were that we had to use exactly 4D flip-flops. We could only use at most one full adder and as many gates and multiplexers as were required. So the design requirements also said that the output had to drive LEDs. So this is logically equivalent and it just drives 4 LEDs, but this is kind of more annoying to read, so I actually made this version which drives 2 7-segment displays. Now, since actually the entire part of it that drives the displays only works on raw logic gates and multiplexers, this still is within design constraints, so it's technically okay. And since these are made of LEDs, it still counts, I would imagine. Either way, these both work the same way. The 7-segment display is driven by a 7-segment decoder. Now, any circuit that works as a 7-segment decoder would work, but I tore the layout straight out of the datasheet, which was a mistake because this took many hours of effort to make work, and this causes a lot of lag, as you'll see later. Now, I didn't actually make this for this project. I took a lot of the stuff in here from the lab section of the digital logic design classes, week 6 and 7 extend and report document, because in that class we had to actually build the BCD converter to 7-segment display circuit in real life, and I had a lot of these schematics on hand. So everything you see where it says binary to BCD converter, everything to the right is straight out of that lab, and everything to the left is the logic portion of this assignment. Now we can demonstrate this works. I can activate the clock, and since all the inputs are set low, this is going to count up the even numbers from 0 to 14. And as you can see, it did exactly that. Now I can switch it to... oh, I didn't click it. I can switch it to odd numbers, and it will just count up the odd numbers from 1 to 15. Now I can make it count down the odd numbers by flipping on the up-down control. And I can make it count down the even numbers by flipping off the even-odd control. And that is the 4 combinations of those settings. Now, if we actually turn on alert, it'll toggle between 0 and 8. Now, to help me in troubleshooting, I actually set the alert to the asynchronous reset of the counter, so if up-down is enabled, as soon as you turn alert off, it will jump to 15, and if up-down is off, it'll jump to 0, as you can see right now. But if it wasn't stated to do that in the design requirements, it was also not stated not to do that, so in theory, if that was detrimental to the circuit working correctly, you just remove this line and it would not do that anymore. And as stated earlier, we could actually just verify that if we count up even numbers, you see this circuit is logically equivalent. 2, 4, 6, 8, 10, 12, 14. So that is my demonstration for the multi-control counter circuit. Thank you, Professor, for watching, and also thank you for giving me a very fun semester of logic problems. This was definitely my sorry. This was definitely my favorite class I've taken at Cal Poly so far, this in the lab. And if you are not my professor, thank you for stopping by and enjoying. If you would like to know how this works in detail, I left the lab report and the CircuitVerse file in the description, so I hope you guys learned something, and Professor, I hope you enjoyed watching this, and have a wonderful day.